So what I really want to kind of emphasize today is the importance of data in our world and get it beyond kind of the soundbite. There's a lot of terms we hear to refer to the radical change that's going on. We have this idea of the fourth industrial revolution, which is biological systems coming together with artificial systems. We have this concept of data as the new oil, which is really the idea that's new gold. I was in a conversation before the event started and somebody asked the question, who has the best machine learning solution? And the answer sometimes is going to be who has the best data. And the best data is going to determine who the winner is in any space. We have digital transformation. I'm willing to bet that if I asked 20 people what that means, I'd get 20 different answers. I think it has something to do with customer experience, but I do hear it used for a whole lot of other things as well. And then we have this idea of business model transformation, which might be something like perpetual to subscription. It might be something like on-prem to software as a service. It can mean all kinds of things. For me, what it means is really changing the value chain and changing the value proposition. And if you're not doing that, you're not really doing a business model transformation. You're just playing with some other lever in the company. But the three terms that I really want to focus on, through this presentation are the terms cloud, and cloud has changed everything in my mind and set a lot of expectations. Neural networks, which is the reason you need to collect data, and of course the data itself. This is a set of slides from the ARM conference this week, and this is the ARM CEO over here, Stephen Sangers, talking about how they've already shipped 150 billion ARM processors. So for those that don't know ARM doesn't actually build CPUs itself. It licenses intellectual property, and other people build the CPUs. And there's 150 billion of those already shipped. And the point they're trying to make is the amount that's going to be shipped, through IoT is many times more than has already been shipped on smartphones and personal computers. So if you think of the way that personal computers plus internet changed the world, and then think of the way that smartphones plus internet changed the world, start to think about the way that IoT plus the internet is going to change the world in even bigger ways than the change we've seen already, when you can collect information from anywhere about anything. So we're going to have, they're predicting 1 trillion end devices by 2035. And so the amount of data that's coming into processing points is only beginning to pick up. So we're only at the beginning of the hockey stick, and it's going to accelerate from here. So if you think there's already a lot of data, it's going to get a lot worse. Not a lot worse, a lot better maybe is probably the better way of putting it. And what's going to happen to that data? Increasingly, that data is going to go into neural networks. And what we're discovering as an industry is that a neural network, given enough connections, given enough enough nodes, is just a really good way of approximating any mathematical algorithm. And we're finding that that's a very powerful process. So in the world of AI, and this is a subset of capabilities in the world of AI, the real shift that has kind of happened over the last 20 years is we've gone from thinking about AI as something you define for a set of rules to AI as something where you learn through experience. And in this particular construct, you learn through the experience of analyzing actual data from the real world. 20 or 30 years ago, we probably had the computing power to do a certain amount of rules. We didn't have the computing power to do neural networks. And we do today, and that's the big change. And I'll talk about what happened there. We're also finding that with neural networks, and a lot of research is going on, that the artificial neural networks that we're making through technology actually do behave the same way as biological neural networks. So there's been some research recently in terms of what does a neural network look like inside a mouse for recognizing an image? And it turns out it's the same as a neural network inside a computer. Another example of that, they've done some research has been done showing how a neural network works when a mouse is navigating a grid, and the navigation system for an artificial neural network works exactly the same. So there is this old joke, the joke that I put actually on LinkedIn recently for those who read my LinkedIn profile, and the joke goes something like, if it's done with Python, it's probably machine learning. If it's done with PowerPoint, it's artificial intelligence. So this joke is trying to say that we kind of use this AI word very liberally and in a way that we shouldn't. And even though I love that joke, I will make the point that for certain algorithmic exercises, it does appear that neural networks act a little bit like biological systems. And I think one of the things that we have to think about, as an industry, probably a lot of people in this room today are thinking, well, my job is to do something with software. In the future, your job might be to do something with an algorithm, or a neural network, and you might have to work out how to license that, for example. So what's really happened here that's enabled this? So I think the interesting thing about innovation is, I think in our imaginations, there's some, great entrepreneur that just, battles all the challenges and just makes things happen. But I think in reality, a lot of times, a lot of things just happen at the same time that allow something to really happen. And what's really happened is obviously the proliferation of computing power, computing devices, whether it's PCs, smartphones, tablets, and now IoT. And the internet came along, so that's all connected with broadband circuits. And then the graphics processing unit was suddenly discovered as being a really good way of doing machine learning. And the graphics processing unit wasn't designed for machine learning, and it was later discovered that it was a really good workhorse for that. If it wasn't for the graphic processing unit, we may not be talking about machine learning today, because we may not have made the progress with getting the training times down for machine learning that we have been able to. We have open source, which has provided a lot of innovation through the base software layers. And of course, we have cloud that have provided this model for experimentation and scale, depending upon what your requirements are. So this has led to a situation where we have lots of data. We now have this new approach to analyzing data that's called deep learning or machine learning. And we can, within the bounds of very narrow definitions of artificial intelligence, we can do some really, really cool things. And so the availability of this compute, this availability of being able to get training times down through graphic processor units, the availability of the data, means your competition will be investing in ways to get competitive advantage through using data and analyzing it. And if you're not doing that, you're going to be at a competitive disadvantage. And then just to get a little bit further out in time, if you think the graphical processing unit changed the world, quantum computing is going to change the world in really amazing ways. So for those who kind of read the news, you might have read recently about Google's announcement where a white paper was leaked, where the white paper claimed quantum supremacy. So there are two basic terms used to differentiate between classical computing and quantum computing. One is quantum advantage, which is where a quantum computer does something faster or more efficiently than a classical computer. And the other is quantum supremacy, where a quantum computer does something that a classical computer cannot do in any practical time frame. In the case of Google, they did something in 4 minutes that the best supercomputer in the world takes 10,000 years to do. Now, they did something that was fundamentally useless. They were able to validate that a random number was actually a random number. So there's not a lot of practical use cases for that. But the fact that they were able to prove it means that we're starting to make progress down this road. And anybody who went to the AI Summit in San Francisco a couple of weeks ago, there was a number of quantum computer companies there. And I think these kinds of things are just going to spur more innovation in this space. And simply put, the power of quantum computing is to be able to do a lot of simultaneous calculations, whereas a classical computer has to do it in a certain sequence, and that's why it takes so long. So one of the use cases that is often mentioned is a recommendation system where you have 100 million customers and 100 million products. A classical computer takes 1 trillion steps to do that. A quantum computer can do that in 1,000 steps because it can do so many things at the same time. In the space that I'm most familiar with, which is networking, I'm fascinated with the idea that one day a quantum computer could calculate every single route in the network at exactly the same time and work out what was really the best path, especially in a SD-WAN context, as an example. So I think that's really exciting. It's obviously nascent. There's a lot of things that are hard about quantum computing today. Quantum computing is so hard today that most quantum computing companies offer a cloud service so you can access their quantum computer rather than actually buy the hardware. But that's really going to dramatically change the world as we know it today. So I want to talk about the on-prem paradox, and based on some comments I've heard today, this might be a little bit of a controversial subject, but let me give you my point of view, and you can agree with it or disagree with it. And what I'm really saying here is that expectations really matter. I made the point before when Jan was talking about how, in my opinion, you can't divorce the B2C market from the B2B market because we're all consumers. And once we have a certain experience, we come to work every day with that expectation. I would make the same about on-prem and software as a service. That once you experience, software as a service, you're going to be inclined to want to have that experience on-prem as well. And if you can't provide that experience on-prem, then you're probably going to be disrupted by somebody who's providing it over as a cloud service. So you've got to really think about how do you manage that situation. The other reasons why trying to keep the experience as consistent as possible is important is because you have two situations where you're going from on-prem to cloud. One situation is where you're getting elastic capacity from the cloud. Another situation is when you're setting a vision for your customer base of everything's going to go to the cloud. So for example, I believe, and maybe somebody can tell me if I'm wrong about this, but I believe that when Microsoft was first trying to get customers to go to Office 365 in the cloud, they kind of had a construct which said you can buy X, Y, Z number of subscriptions and you can use them on-prem or you can use them in the cloud. We don't care. I think if there's anybody here from Cisco, I think Cisco has done this on some of their management solutions as well, where you can buy a certain amount of licenses and you can use them on-prem or in the cloud, right? Okay, as an example, right? So I think given you have that level of consistency, you really want to try to get as many levels of consistency as you can. I'm not saying it's easy or practical, but I think that needs to be your goal. So given my belief, whether you can agree with it or disagree with it, what I'm about to say in the following slides with respect to cloud services, I also believe fundamentally belong to, are applicable to on-prem services as well in the long term. So let me just see if I can work this. Okay, I'm going to change the order a little bit here. I was thinking about it today that this is probably the slide I should have started with. When I was working at Juniper, leading the business model strategy, working with Brett and Nooper and Dave and Jam, the thing that really got me turned on to the idea about measurement and reporting as opposed to using a license key to enable software and having an enforcement motion was the experience of our customers in their networks. So when Brett and I first started working on this problem, and Nooper as well, we had a terrible licensing situation at Juniper. It was just a complete mess. We had different product groups doing different things, and then we had product groups undermining the intention of certain licensing capabilities. So for example, we had some boxes where you had to put in a license key to enable some use of the software. And the customers were upset about every time they put in a new box, you had to use a license key. So then the product managers created this thing, I think it was called a universal key. Is that right, Brett? Yeah. Where basically you could use this one key and use it for any amount of boxes as you want. And suddenly you had no way of tracking, how many licenses were being used. You weren't monetizing the software, all this kind of stuff. So because you had a really, really painful situation for the customer, the propensity of the product managers and the sales force was to say, how do we take that pain away? And they took it away in such a way that there was essentially no licensing approach. So that's when I kind of started to, that was one piece of thing that kind of clicked me into thinking about measurement reporting. The other thing was the fundamental consequence of a cloud world, which is agility, flexibility. You have software instances that might be up for a nanosecond or 2 minutes or 2 hours. Can you really have a situation where you're putting a license key in every time you're bringing up a piece of virtual software? From an operational point of view, it's just not practical. And it's going to get worse because think of where we're going. We've gone from these big monolithic pieces of software to virtual machines and now container-based microservices. So your competition will be sucking in lots of data. They will be using neural networks. They will be getting insights. They'll be adding value to their companies in ways that they haven't in the past. And if you're not doing the same, then you're going to be at a competitive disadvantage. So bottom line here is feed the beast so you can get to better insights and better outcomes for your company. Thank you very much.